The third graders learned how to measure the inside of the shape using area. They learned that area is a measurement of the space that is inside of a shape, and that you can measure a shape's area by filling the space with square units. I connected it to arrays. They used arrays to solve multiplication problems. And they learned that each square unit that we use to measure area represents one square in an array. So if you look at this array right here, this is a 3 by 4 array. And 3 times 4 equals 12. The third graders learned that mathematicians fill a space with square units. That is how they measure or are able to measure the inside of a space, is by using the same size square units to fill the space and to find the measurements of the inside of the shape. So this particular shape can take the same size squares, and it's a 3 by 4, and there are 12 square units that fill that rectangle. And here is another shape we have here. This one is a 2 by 2. So that's 2 times 2, which equals 4 square units. And here there's a connection between the arrays for multiplication and measuring area. And the kids begin to see that area of a rectangle is its length multiplied by its width. And that gives you the number of square units, or the measurement of the inside of the shape. So here this is a 1 by 5. I can fit 5 squares into this rectangle. It is a 5 by 1, 1 times 5. The area equals 5 square units. Another example, we learned that area is the measurement of the inside of a shape. This is very important to stress. Area is the inside, totally different measurement than perimeter that they learned. Perimeter was the outside, area is the inside. So then we jumped from using square units or counting square units and making that a connection with arrays to looking at a rectangle that we have and finding the area by multiplying its length by its width. So this rectangle, it's a 4 centimeter by an 8 centimeter rectangle. The third graders learned that they will multiply the length times the width, and it equals 32 square centimeters. Always square units. Here we have the unit of measurement, which is centimeters. Therefore, it's square centimeters because it's how many squares can fit inside of the shape. So it's a different label than perimeter. Then we jumped to looking at a larger shape, and we learned that we could chop a larger rectangle into smaller rectangles. And then we can find the area of each smaller rectangle, and then we add up the areas to find the whole shape's area. So here, this is a 1, 2, 3, 4, 5 by 1, 2, 3 rectangle. So this shape right here, I would have an equation of 3 times 5, which equals 15 square units. And that's the area of my first rectangle. Excuse me. Then the next rectangle, this is a 2 by 1, 2, 3. 2 times 3 equals 6 square units. That's the area of the smaller one. Then I can add that together, and if I have 6 plus 15, my true areas of the rectangles, I could add them together to get an area of 21 square units. And granted, I could have just found the whole area here 3 times, if I could multiply 3 times 7, But this is just showing the students, showing the kids that you can break up a larger shape into smaller ones, find the shape smaller areas, and then add them together. And this is important when you look at a more complex shape. So if you have a shape like this, I can break it up into two different rectangles. And if I have a 3 by 2, that's 3 times 2, which equals 6 square units. Found the area of one of my rectangles. And then I have a 1 by 4. 1 times 4 equals 4 square units. Then 6 plus 4 equals a total area of 10 square units. Here's another example. If I have a 1 by 3, that's 1 times 3 for this rectangle to find the area, which equals 3 square units. And then here I have a 2 by 1, 2, 3, 4, 5, 6, 7. So 2 times 7 equals 14 square units, because it's the inside of the shape. And then if I add 14 plus 3, which equals 17, so the area of this shape, area equals 17 square units. And then in our last problem, we built our understanding of finding area of rectangles, breaking those rectangles up into smaller rectangles, finding those areas, and then also finding the area of a regular shape like this one, and knowing that we can also break this shape into rectangles. But we have to be careful with our side lengths. So here, I know that this whole side length has a measurement of 10. I don't know the unit, so I'm just going to refer to it as units. If this side is 10, and this little part of that side, which is parallel, is 4, I know that this side is going to have to be 6, this missing side. So I like to find my missing sides before I find my area. So that would be 6. Then I'm going to look at this part of the shape. If this is 6, and then up at the top this is 3, I know that 3 and 3 more will equal 6. Now I can break up this rectangle into 2 smaller rectangles to find the area. I'm going to break it up right here. Now all I need to find the area of a rectangle is my length times my width with a rectangle, and that will equal its area. So I have to be careful that I have the right measurement, that I'm not taking the entire side length when I'm finding the area. So I'm going to find the area of this rectangle. Now with this rectangle right here, I can see I have a length of 4, so that would be 4, and then I have a width of 6. 4 times 6, which equals 24 square units. So I found the measurement of the inside of that rectangle. Now I need to find the area of the rectangle on the top, but I need to be careful because once again I need the proper side length. So I have 6. This is the length of that rectangle, and then I have my width of 3. 6 times 3, which equals 18 square units. Then I'm going to finally, so I found the measurement of the inside of here and the measurement of the inside of here. I'm going to have my total area, and I'm going to add 24 plus 18, which equals 42. So my entire area of this shape, measurement of the inside, 42 square units.